ground has found and brought back many dinosaurs. Here is the head of the dreaded Tyrannosaurus.
Throughout the history of life on Earth, there have been perhaps no other organisms that inspire as much awe as that of the dinosaurs. For 250 million years, dinosaurs have been a staple of life on this planet, from the most colossal sauropods to the mightiest carnosaurs. And even today, with the thousands of species of living dinosaurs that still fly throughout our skies, dinosaurs have been perhaps the single greatest success story in the entire history of life on planet Earth. But even among these most awe-inspiring animals, there is one that outshines them all. Its origins date all the way back to the Jurassic, with the small, feathered creatures that scurried under the footsteps of the much larger dinosaurs. These animals were known as Coelurosaurs, and though they may come from humble origins, their kind would, in time, produce the largest and most revered terrestrial predator that this planet has ever known. Arriving on Earth 68 million years ago, towards the end of the age of the dinosaurs, this massive animal was the one who would rule the dinosaurs in their final days. And though it only reigned for around 2 million years, a mere blink of the eye compared to the vast time span of our planet's history, the legacy it left behind would be that of an almost legendary animal, the likes of which our world has never seen before or since. With a bite force that easily shattered through bone, holding dominion over the entire North American continent, it was the undisputed ruler of the prehistoric world, though perhaps we know it better as Tyrannosaurus Rex, the king of the dinosaurs. While the king of the dinosaurs first appeared on Earth around 68 million years ago, its story actually begins in the year 1874 with the discovery of a single isolated tooth. This tooth, discovered in South Table Mountain, Colorado by Jarvis Hall student Peter T. Dodson, was, along with other fragmentary bones, assigned to the species Ornithomimus grandis by the famous paleontologist Othniel Charles Marsh, before later being assigned to a different genus, that being Dinodon. Other material in 1892 consisting of 2 partial vertebrae would be discovered by the equally famous paleontologist Edward Drinker Cope, who then described the remains as belonging to an agathalmid dinosaur, or what we now know today as a ceratopsid. To this animal he would go on to assign the name of Manospondylus gigas, meaning giant porous vertebrae, though, as is obvious based on the classification he gave this new animal, he was unaware of the significance of said find. find, and almost certainly had no idea that he had come into possession of fossils of the most legendary dinosaur of all time. Cope said classification of this animal as a ceratopsian would not long after come under scrutiny in the year 1907. In that year, the paleontologist John Bell Hatcher, who had previously discovered the famous dinosaurs Triceratops and Torosaurus, would note that the vertebrae of this animal did not actually align with what is known from other ceratopsids, and instead more than likely came from some kind of gigantic theropod. As to what massive theropod that was, the paleontologist Barnum Brown and Henry Fairfield Osborn had just recently unearthed something massive in the years prior. In the year 1900, whilst fossil hunting in Lance Formation in eastern Wyoming, paleontologist Barnum Brown unearthed a partial skeleton of an extremely large dinosaur. 2 years later, in 1902, this time in the famous Hell Creek Formation in Montana, Barnum Brown would unearth another partial skeleton, this time consisting of approximately 34 fossil bones. Writing about this creature at the time, Barnum noted that it was clearly a massive carnivore, and would go on to say, "I have never seen anything like it from the Cretaceous." Brown would later go on to lend the fossils to fellow paleontologist Henry Fairfield Osborn, who would then go on to describe the two skeletons. The first skeleton, while clearly a massive carnivore, was initially thought to have been a different animal than the second skeleton. This first skeleton consisted of bones similar to the second skeleton, but also featured many fossil bones that indicated that the creature itself was armored, as opposed to the animal of the second skeleton, which was not. Osborn would then go on to describe both of these animals in the same 1905 paper, giving the name Dinosaurus imperiosus to the first skeleton found, while reserving a different name for the second skeleton. As for the name of that second skeleton, Osborn would use a mix of Latin and Greek to form its generic and specific name. The generic name coming from the Greek Tyrannos, meaning tyrant, and Sauros, meaning lizard or reptile, with the specific name coming from the Latin Rex, meaning king. He would go on to publish this name ahead of Dinosaurus in the official publication, reading officially as Tyrannosaurus Rex, the Tyrant Lizard King. The next year, in 1906, Osborn would recognize that both animals were one and the same, and would go on to choose the name Tyrannosaurus Rex as his preferred name for the animal, while relegating the name Dinosaurus as a nomen oblitum, a forgotten name. The year after that, in 1907, Manospondylus would be reclassified as a theropod by Hatcher. However, due in part to its extremely limited remains consisting of just 2 vertebrae, one of which having been lost by this point, it would never end up supplanting the name T-Rex. As for the topic of synonymization, this would simply never be brought up. That is, until the year 2000, when a new ICZN ruling announced that any name that had not been referenced in any form of scientific literature for over 50 years was to be considered as a nomen oblitum. This fact meant that while Manospondylus was the original name, due to the popularity of Tyrannosaurus Rex and its subsequent usage in scientific literature, along with the complete lack of any Manospondylus literature during the same period, name priority would be given to Tyrannosaurus Rex, while officially invalidating Manospondylus. Following the classification change for Manospondylus in 1907, Brown would make yet another trip to the famed Hell Creek Formation in the pursuit of dinosaur fossils. During this expedition in 1908, Brown would go on to uncover what was potentially the most iconic Tyrannosaurus Rex specimen of all time. While the initial 2 specimens that Brown had uncovered were quite sparse, consisting of just 13 and 10% completion, this latest specimen consisted of far more fossil bones, with a staggering completion of 45%, nearly half of the animal. What's more, whereas the previous 2 specimens consisted of little skull material, the entire skull was present in this specimen, giving Brown and his team the very first ever look at Tyrannosaurus Rex. Brown would go on to send the fossils to the American Museum of Natural History, where they would be cataloged as AMNH5027, and, due to the completion of the animal, the decision was made to display the dinosaur for public viewing. In the year 1915, the American Museum of Natural History would go on to unveil to the world Tyrannosaurus Rex, the king of the dinosaurs, propping it up in the now outdated tripod stance for for all to see. And though this stance has since been rectified to better represent our modern understanding of the animal, a silhouette of the original upright specimen would find its way onto the cover of a science fiction book in the year 1990 by author Michael Crichton, and then the logo of a Steven Spielberg movie just 3 years later. The book and the movie in question? None other than Jurassic Park. Unfortunately, Brown would not live to see the next Tyrannosaurus rex specimen uncovered. In fact, the years following the display of AMNH 5027 would end up being rather uneventful for T-Rex paleontology, as the outbreak of war in Europe, followed by the Great Depression, and then yet another world war would take most of America's attention away from paleontological endeavors. This combination of historical events would mean that no Tyrannosaurus rex specimens would be uncovered until the year 1966, 3 years after Brown's passing. However, there was a single rather interesting specimen discovered in the year 1942 that would forever change the way we look at Tyrannosaurus. In 1942, while fossil collecting in the Lance Formation of Montana, the curator of the Cleveland Museum of Natural History, David Dunkel, discovered something incredible. From the earth, he brought forth a skull, and one that was clearly from a tyrannosaur, but unlike T-Rex, this skull was incredibly small. After its discovery, this skull would be initially assigned to the genus Gorgosaurus and given the specific name Lancensis for the Lance Formation. In the following decades, it would be reassigned to many different dinosaurs before eventually being given a brand new and far more infamous name by Robert T. Backer, Michael Williams, and Philip Curry in 1988, that being Nanotyrannus lancensis. This skull, as well as other subsequent fossils, would ignite fiery debate in the paleontological community over whether or not Nanotyrannus lancensis was really its own genus, or rather, just a juvenile specimen of the far larger Tyrannosaurus rex. As for the aforementioned Tyrannosaurus rex discovered in 1966, this one would be the first fully confirmed Tyrannosaurus rex to have been found since the discovery of AMNH 5027 by Barnum Brown in 1908, almost half a century earlier. Discovered by paleontologist Harley Garbani, the specimen named LACM 23844, nicknamed Harley after its discoverer, was around 25% complete and featured an incredibly large skull that would go on to be displayed as the largest T-Rex skull anywhere for the time. This would, with the exception of the Cleveland skull, represent the first Tyrannosaurus rex specimen not discovered by Barnum, heralding in a new era of discovery for the tyrant dinosaur. The next specimen to be discovered would be unearthed the very next year in 1967. The specimen, cataloged as MOR008, was discovered by Dr. William McManus in the Hell Creek Formation near Custer, Montana. The specimen, nicknamed Custer after the nearby town in Montana, includes a partially complete and disarticulated skull. This skull, once fully reconstructed, was discovered to have potentially been the largest Tyrannosaur skull known, being larger than that of later large skulls, though many paleontologists have cast doubts as to the accuracy of this reconstruction. The next specimen of Tyrannosaurus rex to be found would be discovered 13 years later in 1980 by a high school student by the name of Jeff Baker, who had stumbled across a bone in a riverbank between the Crow's Nest and Willow Rivers in the Willow Creek Formation. 2 years after this discovery, excavations on the fossil would begin in order to unearth it from the ground. It would subsequently be given the catalog name of RTMP8161 and given the nickname Black Beauty for the striking black coloration of the fossils caused by sediments in the fossilization process. The specimen itself was around 28% complete and featured an almost complete skull, a partial lower jaw, a partial rib cage, as well as some cervical vertebrae, as well as most of the left leg and one upper arm bone, casts of which have been replicated and sent out for display all over the world. Additionally, in the year 2009, paleontologist Jack Horner et al. Would publish a paper detailing parasitic infections in dinosaurs as an illustrated concept by analyzing the lesions present in this particular specimen's cranial bones. While MOR008 had been discovered 13 years prior in the year 1967, the discovery of Black Beauty would mark the beginning of a vast increase in Tyrannosaurus rex discoveries over just the next couple of years, with the next significant find coming just 3 years later. This find would be the first to be found outside of the northern US and Canada, being uncovered in the Hall Lake Formation of New Mexico within the McRae Rock Group, and was discovered by Donald Stanton and Joe LaPointe. The specimen itself was rather sparse and consisted of only the lower mandible, a small portion of the skull, and a single chevron from the tail. Interestingly, while all other Tyrannosaurus rex remains uncovered before or since have been found in formations from the late Maastrichtian stage of the late Cretaceous, dating from 68 to 66 million years ago, this particular specimen is an outlier, being found in a formation that dates to as far back as the late Campanian. In fact, radiometric dating of the fossils have put the estimated age of this particular animal at 72.7 to 70.9 million years old, making this animal roughly 2 to 4 million years older than all other known T-Rex specimens. However, one 2024 abstract suggested a younger age in the locality this specimen was found in, making it 69 million years in age rather than the previously suggested 72.7 million years in age. That being said, this still makes this animal 1 million years older than the next oldest Tyrannosaurus rex specimens. Despite this, due in part to the morphological similarities to Tyrannosaurus rex, this specimen was originally assigned as just an extremely old specimen of the aforementioned T-Rex in 1986. However, in the year 2024, a paper was published detailing anatomical traits that this specimen featured that were different from that of other Tyrannosaurus rex specimens, notably the more slender build of the skull itself, being flatter laterally than that of T-Rex, as well as a slightly different ornamentation of the post-orbital crest on the cranium. The author of this paper, paleontologist Sebastian Dahlmann et al., would then go on to describe this animal as a brand new species of the genus Tyrannosaurus, assigning the specific name Micraensis in reference to the McRae rock group in which the animal was found. Though naturally not all paleontologists agree with this assessment, as seen earlier this year in 2025, supplementary material for a publication that described the intermediate Tyrannosauroid, Canculu, shared detailed information that seemed to indicate that Tyrannosaurus micraensis is not actually a valid species. Leaning heavily on anatomical traits in the skull, paleontologist Jared T. Voris and colleagues conclude that T. micraensis is not diagnosable enough to be a separate species and is, to them, a junior synonym to T-Rex. However, no other publication has since been made that heavily focuses on this ongoing debate, making the validity of T. micraensis contentious for now. The next several years would see two more Tyrannosaurus specimens discovered before the turn of the decade, the first of which being discovered in South Dakota in the year 1987. This specimen, cataloged as BHI 3033, was discovered by amateur paleontologist Stan Sacrison. Sacrisson's initial find was that of a pelvis jutting out of a rock, which he had initially assumed to have been that of a Triceratops. However, as the specimen was unearthed, it quickly became apparent that this was no Ceratopsian, and rather another Tyrannosaur. Nicknamed Stan in honor of Sacrison, this T-Rex would be the first ever found with more than half of its skeleton intact, at a massive 70% completion. Around 30 casts of Stan's skeleton have been replicated and distributed around the world, with each one being sold for around $100,000. The actual skeleton itself was sold to the city of Abu Dhabi in 2020 for $31.8 million for their upcoming natural history museum, which, at the time of sale, was the most expensive dinosaur fossil ever sold, a record which it held until the sale of a Stegosaurus skeleton last year in 2024. The next and final specimen to be discovered in the 80s was found the very next year in 1988. This fossil would be discovered by a local rancher by the name of Kathy Wankel on a small river island in the Missouri River in the Charles M. Russell National Wildlife Refuge. It would go on to be excavated by a team of paleontologists from the Museum of the Rockies led by famous paleontologist Jack Horner, with help of the U.S. Army Corps of Engineers. This specimen would be given the catalog number of MOR 5 555 and was found to have consisted of roughly 80 to 85% completion, beating out the previously discovered stand. Notably, this specimen contained a nearly complete skull as well as the first ever fully complete fossil of the now iconic two-fingered forearm of Tyrannosaurus rex. The fossil would be given the nickname Wankel Rex in honor of its discoverer. The animal itself was estimated to have reached a length of around 11.6 meters or 38 feet, with an estimated average weight of as much as 8.3 metric tons. It was also estimated that the animal was around 18 years old when it died, making it an adult, albeit not a fully grown one. Interestingly enough, scientists were able to find evidence of the biological molecule heme on the inside of the skeleton. Heme is the iron-based molecule that forms hemoglobin, the molecule that allows blood cells to collect oxygen and transport it around the body. This find by Dr. Mary Schweitzer represents the first times that biological molecules were discovered in non-avian dinosaur fossils. Following the discovery of Wankel, the next Rex would not be unearthed for another 2 years. However, this Rex would potentially end up being the most important specimen of Tyrannosaurus Rex ever found. The story of this fossil begins perhaps rather ironically, at the very end of a paleontological expedition. In 1990, a team of paleontologists from the Black Hills Institute had finished up their work searching for fossils in the Cheyenne River Indian Reservation and had left with some Edmontosaurus fossils in tow. However, before the group could depart on August 12th, a flat tire was noticed on their truck, postponing their return journey. While many members of the group stayed behind to fix the flat tire, one person, a woman by the name of Susan Hendrickson, decided to take a short stroll. While the rest of the group was fixing the flat tire, Susan went off to explore some unchecked cliffs nearby, and upon doing so, she stumbled upon several small bone fragments. Immediately upon finding these fragments, she began to look around to find their place of origin and observed even larger bones protruding from the cliffside. She then returned to the campsite with the small bone fragments she had collected, and eventually brought the discovery to the president of the Black Hills Institute, Peter Larson, who immediately recognized the fossils as those of Tyrannosaurus rex. While many of the team still had to leave, a few, along with Susan herself, stayed behind to excavate the fossils, a process which was fully completed in just 17 days. Following this, it was determined that this dinosaur, soon to be nicknamed Sue after its discoverer, was potentially the most complete Tyrannosaurus rex ever uncovered for the time, with 90% of the fossil skeleton having been recovered. And for the time, Sue was regarded as the largest T-Rex ever unearthed in history. However, the years following the excavation of this monumental find did not go smoothly, as the circumstances of this fossil's discovery brought with it many political and legal woes. Following the discovery of the incredible fossil, the question of legal ownership over the skeleton quickly arose. For while the Black Hills Institute had obtained permission for the excavation and removal of the skeleton and paid a fee of $5,000 to the owner of the land, a one Maurice Williams, Williams would later go on to claim that this fee was just for the excavation of the animal and not for ownership of the fossil itself. This was complicated more by the fact that Williams was a member of the Sioux tribe, and the tribe claimed ownership over these bones. However, the property where the bones had been uncovered was actually held in trust by the United States Department of the Interior. This complicated legal situation culminated in an FBI raid of the site where the Black Hills Institute had been preparing the fossil bones. Additionally, Peter Larson was arrested and charged on 158 counts. Following this incident, the government transferred the fossil bones to the South Dakota School of Mines and Technology, where the skeleton would remain until the legal troubles had been worked out. The legal issues would last many years and see Peter Larson charged with customs violations and sentenced to 2 years in prison, while a civil case would decree that Maurice Williams would retain ownership of the fossils, which he then would go on to auction off in the year 1997. Given that the Sioux specimen had gained much prominence during this time, many were worried that once the auction had ended, the specimen would end up in the hands of a private individual where the bones would never be studied or seen by the public. To stop this from happening, the Field Museum of Chicago decided to bid on the skeleton, but was worried about not having enough funds to win the auction, and ended up asking for people and corporations to donate to the cause. To this end, the California State University, as well as Walt Disney Parks and McDonald's, along with many members of the public, donated large amounts of money to help the Field Museum bid on the skeleton, which they eventually won at a price of $8,362,500. Thus thus making Sue the most expensive dinosaur ever sold for the time, and the fourth most expensive ever behind the aforementioned Stan, sold in 2020, a juvenile Ceratosaurus sold this year, and a Stegosaurus specimen named Apex that was sold in 2024. Sue would go on display at the turn of the millennium in the year 2000 on May 17th to an audience of nearly 10,000 people at a grand unveiling in the Field Museum of Chicago, where the fossil still remains to this day. Sue would go on to be the most well-researched Tyrannosaurus rex in all of paleontological history, and is what could very well be the most well-understood non-avian dinosaur of all time. Additionally, the research done on her fossils would help paleontologists understand many different aspects of Tyrannosaur evolution and biology for decades to come. And following the discovery of Sue, a litany of new fossil Tyrannosaurs would be uncovered throughout the next decade, but none would be nearly as important as Sue. However, in 2001, a brand new Tyrannosaur would be unearthed like none ever seen before. The T-Rex specimen BMRP 2002.4.1, otherwise more popularly known as Jane, named after the museum's benefactor, Jane Solom, was discovered in the southern Montana region of the Hell Creek Formation in 2001 and would go on display at the Burpee Museum of Natural History in Rockford, Illinois. Jane is estimated to be 50% complete, consisting of an almost completely intact skull, several cervical and thoracic vertebrae, a shoulder girdle with an upper arm bone, two nearly complete hind limbs, a complete pelvic girdle, and almost the entirety of the tail. Jane was believed to have been 11 years old and reached a body length of 6.5 meters at the time of death, making the specimen over half the body length of the aforementioned Sue. This information alone gives us a better understanding of the early growth stages for the Tyrant Lizard King, and, just like the aforementioned Cleveland skull, Jane has also been the center of the ongoing debate regarding the validity of Nanotyrannus. In fact, the discovery and grand opening of Jane alone brought the formation of a conference held at the museum the specimen was displayed at in 2005. And indeed, at this conference, paleontologists such as Philip J. Curry and others had come to agree that Jane and the Cleveland skull were juvenile specimens of Tyrannosaurus. However, the debate over whether or not Nanotyrannus was a valid genus would still rage on as far as even today. The next important specimen of Tyrannosaurus rex was discovered just 1 year later in the year 2002 by amateur paleontologists Don Wyrick and Dan Wells in Fallon County, Montana. Given the catalog number HMNS 2006.1743.01, it would go on to receive the nickname Wyrex after its discoverer Don Wyrick. This specimen would be excavated 2 years later in 2004 and was around 38% complete. However, a large chunk of the missing material would end up being from its tail. Interestingly, the parts of the tail still present did show signs of damage and trauma, indicating that the tail wasn't just missing from the fossil remains, as it appears to have been missing from the animal while it was still alive. In fact, it has been proposed that the tail was actually ripped off Wyrex by another Tyrannosaurus. But rather interestingly, there appears to be signs of healing over the damaged tail, indicating that this animal didn't die from this extremely traumatic injury, but rather survived long enough for the healing process to take effect. This recovery has some incredible implications for Tyrannosaurus sociality, as it begs the question of how Wyrex was able to hunt and survive while in a near crippled state, with some paleontologists suggesting that the animal was part of a social group that was able to help provide food while Wyrex was injured. The recovery is also a testament to just how resilient dinosaurs are. However, the lack of tail due to a traumatic injury and its subsequent recovery is not the only interesting thing about this particular specimen, for Wyrex also contains the most well-preserved tyrannosaur feet ever found, in addition to extremely well-preserved arms, but perhaps most intriguing is the integument that was found with the fossil. Wyrex is one of the few tyrannosaur specimens that preserves skin impressions in the fossils, and these skin impressions all show small, pebbly, scaly skin, in contrast to the Coelurosaurian nature of Tyrannosaurus rex, which would have initially suggested a more feathery appearance of the animal. These skin impressions are known from the tail, back, legs, and neck, and showcase that Tyrannosaurus rex likely would have been nearly entirely scaly. And lastly, the final important specimen of the 2000s is, as with Jane, yet another juvenile Tyrannosaurus specimen, cataloged as BHI 6437 and nicknamed Bloody Mary. Bloody Mary is the most complete Tyrannosaurus specimen ever recovered at a 98% completion, but that's not all, as this fossil Rex was found locked in combat with an equally complete young Triceratops. This fossil, known as the Dueling Dinosaurs, is an incredible find, showing both dinosaurs locked in some sort of battle, making it North America's equivalent of the famous Fighting Dinosaurs fossil from Mongolia, where a velociraptor and a protoceratops died while locked in battle. The fossil itself was discovered in Montana by the ranchers Clayton Phipps, Mark Eatman, and Chad O'Connor in 2006. Both dinosaurs remained obscure from the public until 2011, when a website with a marketing campaign was launched in an attempt to sell the Dueling Dinosaurs fossil. Both the ranchers and surprisingly Pete Larson, who also collaborated with its marketing, failed to sell the fossil to museums like the Museum of the Rockies and the Smithsonian. Instead of hoping a museum would buy the fossil, they intended to look for a private collector instead. After Bloody Mary was named and cataloged in 2013 during an annual meeting of the Society of Vertebrate Paleontology, the presentation that showed the dueling dinosaurs was met with controversy, with many questioning their practices of trying to sell the fossil to a private collector due to Bloody Mary being a potentially extremely important find in order to better understand the Nanotyrannus debate. In 2016, American paleontologist Lindsay Zano started negotiations with Phipps to purchase the fossil and started raising funds at the North Carolina Museum of Natural Sciences. However, negotiations began to slow down due to legal issues regarding the ownership of the fossil. A 2018 court case between the owners of the land where Bloody Mary was found ruled in favor of the Seversons family instead of the Murrays due to fossils being considered as minerals, which angered paleontologists. Fortunately, the case was appealed to the Montana Supreme Court in 2020, disagreeing with the assessment that fossils should be considered as minerals. This resulted in the Dueling Dinosaurs fossil being legally owned by the North Carolina Museum of Natural Sciences, and it remains under study by the paleontologists there. And in April of 2024, the exhibit of the fossils was officially opened to the public and remains on display to this day. Following Bloody Mary, another 10 Tyrannosaurus rex specimens would be unearthed over the next 20 years, with many more fragmentary remains being discovered as well. One of such remarkable finds was in 2022 with the discovery of yet another young T-Rex specimen known by a nearly complete skull, a complete pelvic girdle, a nearly complete right hind limb, and other fragments. It has since been given the simple nickname Teen Rex. Discovered in Marmarth, North Dakota, the specimen was 13 to 15 years old when it died, and was the main inspiration for the 2024 Giant Screen Films documentary, T-Rex. And lastly, the most recent of these specimens, being itself fragmentary, consists of just a single bone. This bone, discovered in 2024 in Harding County, South Dakota, is a fossilized femur that would be unearthed by Lauren Gertsch and Lauren McLean in the Hell Creek Formation of South Dakota. However, this find is of particular interest to paleontologists due to its truly massive size. This femur is by far the largest ever found in Tyrannosaurus history, measuring 137.1 centimeters long and 64.77 centimeters in diameter, raising the possibility that the animal it came from may have been the largest terrestrial predator to ever live. All in all, Tyrannosaurus rex has one of, if not perhaps the richest history of any dinosaur ever discovered, with a great deal of extremely well-preserved specimens known to science. In fact, there are so many known specimens that our own rather long summary of its discovery here leaves out a great deal of animals. That said, the story of Tyrannosaurus rex is far from over, and there are doubtless many more yet to be discovered specimens just waiting to tell us even more about the king of the dinosaurs. When Tyrannosaurus rex was first discovered, scientists didn't have the most accurate view of this animal, and paleontology as a whole had only just begun to accept the idea that dinosaurs were actually bipedal, even if they were being reconstructed in a kangaroo-like tripod stance. And upon the discovery and description of Tyrannosaurus rex, this depiction was given to it as well. In its upright posture, the animal was estimated to be incredibly tall, at a monumental 5.7 meters or 19 feet in height, and its length was set to be close to 40 feet or 12 meters. As for weight, this animal was originally speculated to have been 14 tons at its maximum estimate, making Tyrannosaurus rex an almost absurdly large animal. This depiction remained the same until the dinosaur renaissance, when T-Rex was given a more bird-like and horizontal posture, decreasing its height to a more reasonable 12 feet tall. However, in the early 90s, a brand new depiction of this animal would take the world by storm. In 1993, with the release of the movie Jurassic Park, the public would get its first look at what, for the time, was the most accurate depiction of Tyrannosaurus rex ever put to film. This animal was seen to be on screen at a massive 5 meters in height and 13.5 meters in length, making it significantly larger than the actual animal. However, due to the immense popularity of Jurassic Park, this would be the depiction of Tyrannosaurus rex that would stick with the public for roughly the next 20 to 25 years, until the debate around feathers in Tyrannosaurus became rather prominent. Speaking of which, around the late 2010s, following the discovery of Eutyrannus, a fully feathered fossil of a proceratosaurid tyrannosauroid, a new depiction of Tyrannosaurus rex as a fully feathered animal began to make the rounds in the scientific community. For several years, this remained the most scientifically accurate rendition of the tyrant dinosaur ever reconstructed. However, new scientific evidence began to be unearthed that started to cast doubt on the feathered reconstruction, favoring a less feathery and more scaly animal, which brings us to today. The modern-day Tyrannosaurus rex is still an extremely massive animal, coming in at roughly 3.6 to 4 meters or 12 to 13 feet in height, with a weight of around 9 metric tons, making it potentially the heaviest theropod dinosaur to ever live. As far as length goes, the aforementioned specimen Sue was considered to be the largest complete specimen for some time, reaching a total length of 12.3 to 12.4 meters or 40 to 41 feet. However, a 2019 study concluded that another specimen, the one discovered right after Sue, nicknamed Scotty, was slightly larger and estimated to reach a total length of 13 meters or 43 feet in length, with an estimated mass of 9.7 tons. This makes Tyrannosaurus rex similar in length to Giganotosaurus, also at 43 feet, and slightly shorter than Spinosaurus at 46 feet, while still being the most massive theropod dinosaur ever known. However, Scotty is only the largest known Tyrannosaurus rex specimen, with the benefit of a mostly complete skeleton at 70% completion. Another specimen, however, that being BHI 6248, nicknamed Cope after the famous paleontologist, is far more fragmentary in nature, though its bones seem much larger than the corresponding bones of Scotty, which would indicate that Cope was a much larger tyrannosaur, having a mass of around 11 metric tons. However, due to the fragmentary nature of this specimen at only 10% completion, this estimate is subject to debate. Additionally, in 2024, an isolated Tyrannosaurus rex femur was discovered in South Dakota. Remarkably, this fossil, nicknamed Goliath, ended up being the largest femur ever discovered in the history of Tyrannosaurus paleontology, with a length of 137.1 centimeters or 4.49 feet and a circumference of 64.77 centimeters or 2.125 feet. This femur easily outsizes the femurs of Sue and Scotty and is significantly larger than that of Cope's. It is worth noting, however, that the upper and lowermost ends of the femur were damaged in transport, so the femur could be slightly longer than currently estimated. While this femur is all that is known of this particular animal, estimates have been made suggesting that if the proportions of this animal remain the same as what one would expect for a tyrannosaur, the mass estimate estimate of this Tyrannosaurus rex could reach 12 or even 12.5 tons in weight, far larger than any other theropod dinosaur ever known. Of course, due to the extremely fragmentary nature of this individual, this estimate should be considered highly speculative, with Scotty being a much more reasonable estimate for Tyrannosaurus rex average upper end mass. However, Goliath does show us that truly titanic tyrannosaurs were not only possible, but did in fact exist. It's also worth noting that a 2025 publication by paleontologist Matthew Dempsey and colleagues suggests that the current weight estimates for Tyrannosaurus overall could be around 10% heavier than what's currently supported, so it's possible that the king of the dinosaurs may have been even bigger than what we currently think. As for the life appearance of this animal, it would have been extremely robust compared to other predatory theropod dinosaurs like the aforementioned Carcharodontosaurus, and even more so than its own family members, featuring an extremely wide skull that would have been capable of delivering a massive bite force. Along with its massive head, it is also known for having rather small arms relative to the size of this monumental animal. Though while these arms do appear small, this is actually rather deceptive, as these arms are not only longer than those of an adult human, but they are also extremely strong, with each arm capable of lifting around 200 kilograms. This is in contrast to other dinosaurs with famously small arms like Carnotaurus and members of its respective family, whose arms could not perform any meaningful feats of strength and were truly vestigial. On the other end of the animal, we arrive at its tail, which was both long and heavy in order to counterbalance the immense weight of the front end of the animal. In fact, the tail itself was around 20 feet in length and accounted for roughly half the length of the entire animal along its 40-plus caudal vertebrae. Though perhaps rather interestingly, the exact number of tail vertebrae is unknown, and quite possibly even varied between different individuals. As for Tyrannosaurus rex's closest relative, this would be the recently named Tyrannosaurus micraensis. While one of the largest tyrannosaurs known, it would still end up being slightly smaller than T-Rex, coming in at 10 to 12 meters, or 35 to 40 feet in length, and weighing in around 8 tons. Based off the shape of its skull, we can also see that this was indeed rather slender in comparison to its more well-known cousin. Though as far as Tyrannosaurus rex relatives go, Tyrannosaurus micraensis was not the only massive dinosaur known. When Tyrannosaurus was first discovered, it was initially classified into a group of dinosaurs known as Carnosauria. Today, Carnosauria is known as a clade that features many large theropod dinosaurs, most notable of which being the Allosaurs and the respective kin, and potentially even the Megalosaurs, though this is more controversial. However, back when Tyrannosaurus rex was discovered, Carnosauria was a sort of wastebasket where all large predatory dinosaurs were assumed to have presided, and Tyrannosaurus rex, being the largest predatory dinosaur, was categorized into this group as well. However, as time went on, it became more and more clear that Tyrannosaurus rex didn't really have any of the diagnostic features that allowed scientists to classify many of the other carnosaurs. But if Tyrannosaurus rex wasn't a carnosaur, what type of dinosaur could it have possibly been? Less than 10 years after the discovery of Tyrannosaurus rex, a new clade of dinosaurs would be created in order to house all of the much smaller dinosaurs that were very clearly not carnosaurs. Named for their hollow tailbones, this group was given the name Coelurosauria. For an incredibly long time, there would never be a connection made between the king of the dinosaurs and this clade for the very smallest ones, and T-Rex would remain, even if oddly so, a carnosaur. This would all change in the mid-90s, when Coelurosauria would be given a proper classification as all dinosaurs closer to birds than to animals like Allosaurus. Under this new definition, many small theropods that had traditionally traditionally been considered to be Coelurosaurs due to their size were taken out. But perhaps most surprisingly, it was revealed that Tyrannosaurus rex itself was actually an extremely advanced Coelurosaur, and potentially the largest member of the entire family. Within the clade Coelurosauria, it can be found within the superfamily Tyrannosauroidea, which is actually a sister group to Maniraptora, the group of dinosaurs that contains animals such as Oviraptorosaurs, Alvarezsaurs, Therizinosaurs, Ornithomimosaurs, the rather famous raptors known as Dromaeosaurs, and of course, birds themselves, making Tyrannosaurus rex one of the dinosaurs most closely related to the dinosaurs that still live on our planet today. Within Tyrannosauroidea, there are two primary clades, the first of which being the mostly crested Proceratosauridae. This clade, named after the eponymous dinosaur Proceratosaurus, is the clade where the most basal and earliest members reside, containing animals such as Proceratosaurus itself, the famous Guanlong, and the gigantic and also feathered Eutyrannus. The fact that Eutyrannus was fully feathered in its fossils, as well as the entire family's close relation to modern-day birds, has huge implications for Tyrannosaurus rex when it comes to integument and the debate over whether or not T-Rex did or did not have feathers in life. Though, as we've mentioned in History and Discovery, the aforementioned Y-Rex specimen was found to preserve patches of tiny fossilized scales. The paper that described the scales seemingly indicated that T-Rex was indeed featherless and had a portion of scales on its body, with scales similar to what's seen on the legs of birds. This also raised a rather agreed-upon hypothesis that younger tyrannosaurids were born with feathers to regulate their body temperatures, but gradually lost these feathers once they reached adulthood, although it's worth mentioning that this could change in the future due to a lack of data. Alongside the basal Proceratosaurids are the more derived subclades Pantyrannosauria and Eutyrannosauria. Described in 2018, these subclades separate other members within Tyrannosauroidea. Pantyrannosauria contains smaller and earlier members such as the Jurassic Stokiosaurus, the Chinese Dailong, the South American Santanaraptor, Susquityrannus, formerly known as Zunityrannus, and many more. Additionally, a new genus of Tyrannosauroid named Canculu mongoliensis was described in 2025. Coming from the Turonian-aged Bianchiri Formation in Mongolia, the new taxon has both basal and derived tyrannosauroid features. This potentially makes this taxon the first of a brand new transitional subclade that thrived during the earlier stages of the late Cretaceous. As time went on, the Eutyrannosauria subclade would evolve. This subclade contains the later and larger members of Tyrannosauroidea, such as the Southeast Appalachiosaurus, New Jersey's Dryptosaurus, the true Tyrannosaur mimic Pistachiaversor, and the entirety of Tyrannosauridae. The cause of this sudden size change occurred within the beginning of the late Cretaceous, during an extinction called the Cenomanian-Turonian boundary event. By this time, other large theropods like the Carnosaurs were at the top of their food chain, and their control over the apex predator niche is why Tyrannosauroids stayed in the shadows for the longest time. However, due to a chain reaction of underwater volcanic eruptions, global warming, and rising sea levels, the climate of the Earth would start to change drastically, contributing to the downfall of the massive Carnosaurs. And unlike the large theropods before them, Tyrannosaurs would survive and gradually take their place as the top predators. Within Tyrannosauridae, there are two major sister subgroups, those being Albertosaurinae and Tyrannosaurinae. Albertosaurinae is a rather small subgroup that consists of just two genera, those being the type genus Albertosaurus and its sister taxon Gorgosaurus. What sets them apart from Tyrannosaurinae is their lanky builds and skull anatomy, showing that they were rather fast theropods and could still deliver a nasty bite. As for Tyrannosaurinae, this is the subfamily where tyrannosaurs most closely related to T-Rex reside, within which there are 4 to potentially 5 major tribes, the first of which is Alioramini, whose placements were traditionally considered the most basal to the subfamily until 2025, when the discovery of Canculu showed that they were surprisingly derived members within their family tree despite retaining primitive and juvenile-like traits seen in non-tyrannosaurid tyrannosauroids and young tyrannosaurids. The group Alioramini contains the type genus Alioramus with its 2 species, and the larger Chanzalsaurus, also known as the Pinocchio Rex, with just 1. As evident with Albertosaurinae, they also had lanky builds, but had far more slender jaws, which gave them a weaker bite compared to to other members. While they were initially believed to be the most basal members of Tyrannosaurinae, this is now no longer believed to be the case with the publication of the recent Canculu paper. More to this point, no members of Alioramini have been found earlier in the fossil record than the earliest members of the Teratophoniinae tyrannosaurs. Teratophoniinae contains animals like the type genus Teratophonius, Dynamoptera, and the gore king Lythranax. Teratophoniinae, being the most recently described tribe, is unique for containing the earliest true tyrannosaurid members on record, with Lythranax appearing as early as 81 million years ago. Interestingly, Teratophoniinae is also considered as a sister to another unnamed clade where Nanuqsaurus and possibly the newly named Asiatyrannus reside, as well as the more derived Dasplatosaurinae. Dasplatosaurinae, described in 2020, is a rather small tribe that comprises the monospecific Thanatothyristes and Dasplatosaurus, which contains a total of 3 to possibly 4 species. However, the 4th species in question is also potentially the type species of the previous genus, that being Thanatothyristes degrutorum, described in 2020. However, if it turns out that Thanatothyristes is in fact just another species of Dasplatosaurus, this would make this tribe either monogeneric or place Dasplatosaurus back into Tyrannosaurinae, the tribe that Tyrannosaurus itself resides in. Tyrannosaurinae is the final and the most advanced tribe in this subfamily, and consists of 3 different genera, all of which are some of the largest theropod dinosaurs ever described. The first 2 genera to appear are found in Asia, those being the relatively obscure Zhucheng tyrannus, as well as the somewhat well-known Tarbosaurus, both of which have been considered on numerous occasions to be junior synonyms of the 3rd member of this tribe, that of course being the Tyrant Lizard King itself, Tyrannosaurus. Up until extremely recently, Tyrannosaurus had been a monospecific genus, with the type species Rex being the only member recognized, though as was discussed earlier, this has since been updated to include another species, that being Tyrannosaurus micriensis. Tarbosaurus and Tyrannosaurus micriensis, while both large animals, were rather slender when compared to the extremely robust and tanky Tyrannosaurus rex. While most, if not all, Tyrannosaurs have binocular vision, none are more exaggerated than T-Rex itself. Tarbosaurus, by comparison, has the most laterally slender skull, while T. micriensis shows slightly more exaggeration in lateral skull shape. If that's not all, T-Rex is the most heavily built Tyrannosauroid ever found, making it far more advanced than any other ancestor, old or new. Everything from its musculature to even its skeleton show how incredibly robust Tyrannosaurus rex was in comparison to its closest relatives like the aforementioned Tarbosaurus. All in all, the family of tyrant dinosaurs that Tyrannosaurus rex calls its home is one of the most fascinating in the entire dinosaur family tree, and showcases how even the smallest of dinosaurs, if given enough time and the right opportunities, can grow into the most legendary predators that planet Earth has ever known. However, some of these animals are far more controversial than others. While Tyrannosaurus rex was the largest terrestrial predator that this world has ever known, it did not start out that way. Being a reptile, today we know that the king of the dinosaurs started life in a small, humble egg, just like its close relatives alive today. However, the nature of what exactly hatched out of these eggs has changed over time. Initially, it was assumed that, like most reptiles alive today, baby rexes looked rather similar to adults, with maybe a few exaggerated features, but overall, still recognizable as Tyrannosaurus. However, as fossils from other animals from all around the world began showing up in the same formations as giant tyrannosaurs, this notion began to be questioned. One of the first fossils was found in the 1960s and of an animal that was initially described as Shanshaноsaurus by paleontologist Dong Jiming. This animal was rather small but clearly a tyrannosaur, as noted by paleontologist Gregory S. Paul in 1988, and eventually it was realized to have actually been an extremely rare specimen of a juvenile Tarbosaurus, one of the close relatives to T-Rex. Rather interestingly, this specimen showed that juvenile tyrants did not share the same proportions as their adult adult counterparts, maintaining a far more lanky build like more basal tyrannosauroids. Interestingly, in the same year that Paul had recognized that Tyrannosaurus was a tarbosaur, another tyrannosaur across the Pacific Ocean would receive a formal classification. Discovered all the way back in the early 1940s, the specimen initially described as Gorgosaurus would be given a brand new name, Nanotyrannus lancensis, meaning small tyrant of the Lance Formation, named after the formation where it was first discovered. The description of this animal would ignite what was potentially the fiercest debate in all of Tyrannosaurus rex paleontology with one single question. Was Nanotyrannus a valid genus or a juvenile Tyrannosaurus rex? The debate around Nanotyrannus initially revolved around two major fossils, the Cleveland skull discovered all the way back in 1942 and Jane, a large specimen that was discovered in 2001. Both of these specimens contain within them several features that adult tyrannosaurs do not have, the most prominent of which being the tooth count and a small dimple in a bone in the skull called the quadratijugal. For the tooth count, both Jane and the Cleveland skull showcase around 14 to 15 tooth positions in the upper jaw and 16 in the lower jaw. This is in contrast to Tyrannosaurus rex, which has only 11 to 12 tooth positions in the upper jaw and 11 to 14 in its lower jaw. This would seem to imply that if Nanotyrannus was a juvenile T-Rex, tyrannosaurs would have had to lose tooth positions, not just teeth themselves, as the animals grew up, which a few paleontologists insist is unlikely. On the other hand, we have the quadratijugal bone. This is a bone in the skull of both animals, but where in Tyrannosaurus rex individuals no dimple is known, but in both Jane and the Cleveland skull there is a dimple. This would seem to suggest that these were separate animals, as some might expect the adults to have this feature too, which they indeed all lack. However, this feature actually is present in Albertosaurines and Dryptosaurus, and as such, paleontologists like Joshua Schmerge have argued that Nanotyrannus might actually be another Albertosaurine like Albertosaurus and Gorgosaurus, though other paleontologists such as Thomas Carr and colleagues have cast doubt upon this conclusion, stating that this feature isn't conclusive enough to make such a claim, and indeed other paleontologists have concluded that this feature simply vanished in adult specimens, but was present in younger individuals. Additionally, a 2020 publication by American paleontologist Holly Woodward, along with her colleagues, concluded that all Nanotyrannus specimens were ontogenetically immature, making them younger individuals of T-Rex. The paper argues that there is no sexual and phylogenetic variation, and Carr states that the phylogenetic importance of these specimens gradually decreases at the same time as growth occurs. In addition, Carr concludes in this paper that all Nanotyrannus specimens form continual growth transitions from juveniles to subadults, which creates an important bridge in the growth series of T-Rex, and therefore makes Nanotyrannus a junior synonym of Tyrannosaurus. However, a 2024 study by paleontologists Nick Longrich and Evan Thomas Ciata has re-examined the holotype and other referred specimens of Nanotyrannus, resulting in what they see as major differences between morphological structure and growth rates. The paper makes several arguments about ontogenetic growth, the speed of their growth rates, and the overall difference in morphology between both Nanotyrannus and T-Rex, of which the paper concludes that there are more than 150 different morphological characteristics, which include skeletal fusions and skull bone textures. In addition, they argue that the ontogenetic growth between T-Rex and Nanotyrannus is rather different, showing that the genus had a slower growth rate in contrast to T-Rex, and the morphological structure is rather different to the ontogeny of other tyrannosaurines like the closely related Tarbosaurus. While this paper does indeed contain a plethora of other evidence to back up the validity of Nanotyrannus, major tyrannosaur experts have argued against this paper and still consider Nanotyrannus as a junior synonym. As it stands now, Nanotyrannus is in a strange gray area, and it won't be long until a future publication argues against it. Despite the controversy, if these specimens from Nanotyrannus are indeed juvenile rexes, then this would mean that rexes were born with lanky builds as well as long and slender skulls between their hatchling and adolescent stages. As they reached subadulthood, however, their skulls eventually deepened, and their lanky proportions would become more robust, muscular, and tanky. This would seem to indicate that young and old rexes occupied different ecological niches, suggesting possible niche partitioning. Additionally, Tyrannosaurus rex is known to have had one of the most extreme growth rates of any tyrannosaur, growing from just half a ton to nearly 8 tons in weight in just 10 years. Overall, while there's many controversies regarding if younger specimens are actual juvenile rexes or not, paleontologists have a great understanding of how Tyrannosaurus grew, and in turn, how this amazing animal would have survived in its ecosystem across its many different stages of life. Tyrannosaurus rex lived in what is now the Hell Creek, Lance, Willow Creek, Frenchman, Scollard, Ferris, Laramie, Denver, and potentially the Lomas Colorados formations. Its fossil record in these formations shows that this species had an extremely wide range, stretching from possibly as far south as northernmost Mexico to as far north as southernmost Canada. Unfortunately, it is unclear if T-Rex stretched even further to the eastern side of the continent despite the western interior seaway receding millions of years beforehand. During its 2 million year existence, T-Rex served as the apex predator of its environment, inhabiting lush wetland regions, including floodplains, swamps, and similar damp ecosystems. Hell Creek's environment in particular is usually compared to the Florida Everglades. Remains have also been found in coastal deposits thanks to the existence of the western interior seaway, which by this time no longer split the North American continent in half. Interestingly, older studies and documentaries suggest that T-Rex and its contemporary fauna lived in rather volcanic environments, but now that's no longer the case. The flora that T-Rex was surrounded by, while rather primitive, is still surprisingly close to what we see in our forests today. Smaller vegetation consisted of both flowering and non-flowering plants such as various types of ferns, horsetails, lycopods, flowers, lily pads, and mosses. Early grasses also existed during this time. However, they were extremely rare in the Cretaceous. Taller plants included various cycads, ginkgos, palms, primitive magnolia trees, pine trees like the extant redwood sequoia, metasequoia, the extinct podocarpoxylon, and many more. Some fossil formations that T-Rex resided in, like Hell Creek, have also preserved fossilized seeds, which helped confirm that the temperature was warmer and wetter than it is in the American Midwest today. Due to the fact that no Tyrannosaurus nests have ever been uncovered, it's unclear how many eggs were laid and how many hatchlings were usually born. As mentioned before in Ontogeny, however, we do have a good idea of how these animals grew. While juvenile specimens are rare, and considering we have never found a single Tyrannosaurus hatchling, we do know that younger individuals were very lanky, lightly built, and also had long, slender snouts, features which are rather similar to the Asian Alioramini tyrannosaurids. These traits indicate that juveniles and teenagers occupied a speedy predator niche, something in contrast to the adults, which had bulky muscular builds, larger skulls, and were designed to ambush large and tanky prey. The life of a rex would have been far more tough for hatchlings, juveniles, and teenagers, since they would have had a lot of predators and other dangerous animals to worry about. Their diets would have varied from small reptiles like the lizards Chamops and Obamodon to amphibians like Habrosaurus and Albernerpeton, and mammals like Cymolestes, Alphodon, Purgatorius, and many more. However, larger lizards and mammals like Didelphodon and Paleosaniwa potentially targeted hatchlings and slightly older individuals, but as juveniles and teenagers, they would have made easier prey items. Birds that lived during this time made for easy prey as well, which included Hesperornithines like Brodavus and Potamornus, the primitive but dubious waterfowl Styginetta, and potentially Avasaurus, and the newly named Magnusavus. The Alvarosaurid Triararchicus would have also been on the menu of younger rexes considering their small size. Older juvenile and teenage individuals, however, would have hunted smaller dinosaurs such as ornithischians like the ceratopsians, Leptoceratops, Montanaceratops, and potentially the controversial Tatankaceratops, Pachycephalosaurs like Sphaerotholus, Platytholus, and possibly Pachycephalosaurus itself depending on the size of the individuals, as well as thescelosaurids like Thescelosaurus. Other theropods on their diet would include dromaeosaurs like Acaroraptor and the chimeric Dakotaraptor depending on the size of the individual. Additional prey items included the ornithomimids, Struthiomimus, and Ornithomimus itself. and canagnathed oviraptorosaurs like Eoneophron, Anzu, and possibly other genera like Cytopes and Elmosaurus based on similar but also indeterminate remains. As evident with the stomach contents of a Gorgosaurus according to a 2023 publication, it's possible that rexes at this age would primarily eat the hind limbs of oviraptorosaurs too. Other potential prey items likely included the troodontid Pectinodon and other troodontids of indeterminate origin. Predators that young individuals like these had to worry about over the course of their growth were reptiles like pterosaurs, specifically asdarchids like Whelanopterus and Quetzalcoatlus, with their stork-like bodies showing that they were capable of hunting on the ground. Other predatory reptiles consist of animals like the Chrystidae Champsosaurus and crocodilians like Borealisuchus, Thoracosaurus, Brachychampsa, and others that inhabited waterways. Smaller rexes may have also on occasion encountered marine reptiles such as mosasaurs, specifically mosasaurines of indeterminate origin. However, if these marine reptiles were beached, they would easily become a feast for any predator along the shores of its preferred range. Not only did young individuals have to worry about the aforementioned predators, but they also had to worry about the larger herbivores in the region. The largest herbivores around included the likes of the ceratopsids, Triceratops and Torosaurus, the giant hadrosaur Edmontosaurus annectens, and the armored Ankylosaurs, Denversaurus, and Ankylosaurus itself. With the sharp horns of the ceratopsids, the muscular tail and hoofed forelimbs of Edmontosaurus, and the armored tails of the Ankylosaurs, their aggression towards predators would make the lives of young rexes far more tough than people typically imagine. However, on the chance that a younger individual survived to adulthood, there would be almost nothing that could stop a hungry, 9-ton muscular tyrannosaur. For adult rexes were at the very top of the food chain. While it is often commonly believed that tyrannosaur vision is based on movement, this assessment is not true at all. In fact, the skulls of rexes show a very clear case of binocular vision. Their vision alone is actually strong enough to see further than even modern birds of prey such as hawks and eagles. The aforementioned dangerous herbivores would have also had to defend themselves from a mouth that can bite down on prey with a force of around 5 to 9 tons. A 2019 study analyzed the cranial kinesis of tyrannosaurids, showing that all of the articulate parts of their skulls were completely fused together. Recent studies have concluded that tyrannosaurs were specifically designed to hunt prey like hadrosaurs, and in this case for T-Rex, that would be Edmontosaurus. Additionally, there is also evidence to support rexes having hunted the horned ceratopsids. Prey like Triceratops and Torosaurus were far more difficult since their weakest spots, those of which being their backs and necks, were defended by thick hide and their frills. However, if there was more than one individual, rexes would have had an advantage. In addition, it's also hypothesized that due to Tyrannosaurus bite marks on the frills of said ceratopsids, there's a chance that adult rexes were capable of biting onto the frills of these animals in order to use their immense power to rip the heads of their prey clean off their necks in order to feast on their nutritious flesh and bone. As for ankylosaurs, they are far too armored and well defended to usually be hunted by these predators. However, if they had had their vulnerable undersides exposed, they'd make an easy meal. As the king of the dinosaurs, the only true competition they would have had were pterosaurs such as the giant giraffe-sized Quetzalcoatlus. While Quetzalcoatlus northropi would have had an advantage due to its ability to fly, they would have still been vulnerable due to their lightweight bodies. Outside of the formations T-Rex is confidently known from, there are other formations that have recovered remains of Tyrannosaurs from places like the Javelina and Ojo Alamo formations of New Mexico and Texas. If T-Rex itself did indeed live in these far southern regions of North America, it would have lived with different fauna, preying on large animals like the Hadrosaurus, Cretosaurus, and others of indeterminate origin, ankylosaurs like the Nodosaur Glyptodontopelta, and ceratopsids like Ohoceratops. If that's not all, it also possibly would have lived with the last and the largest sauropod to have inhabited North America, America, that being the titanosaur Alamosaurus. Supporting evidence of both Alamosaurus and T-Rex existing in the same region can be found in the North Horn Formation in Utah. T-Rex individuals that lived further down south would have occasionally gone after young, sick, or injured individuals, and in these southern regions, they still had little to no competition. The only predator younger individuals had to deal with was the Dromaeosaur Dinobellator. Overall, T-Rex would have played a major role in its environment. The adults and their offspring not only maintained different niches capable of bringing balance to herbivores big and small, but they were also able to maintain this role for millions of years, including its ancestor T. micryensis. While most, if not all of the formations that T-Rex lived in had local fauna that remained mostly the same, its earlier relative T. micryensis was rather different, as it lived in the Hall Lake Formation in the early Maastrichtian. The Hall Lake Formation info is rather limited in the locality T. micryensis is known from, only showing that it hunted ceratopsids like an unnamed Triceratops species and a close relative by the name of Sierraceratops. There are also unnamed crocodilians and turtles from the same region as well. While T-Rex did have little to no competition, there is one predator that both the adults and younger individuals had to worry about, and those predators were their own kind. Like many predators, tyrannosaurs would not have been opposed to eating members of their own species if the opportunity arose. In fact, what is perhaps the biggest predator younger rexes would have had to look out for would have been larger adult rexes. While this behavior of adult rexes consuming younger rexes for food is entirely speculative, there is solid evidence for cannibalism amongst adult tyrannosaurs, particularly with specimens like AWMM-IL 2022.9, nicknamed Peter. Peter is a Tyrannosaurus rex specimen that was discovered in 2018 in the Lance Formation and is hypothesized to have been killed by another tyrannosaur due to large portions of the skeleton such as the femur and tibia having been damaged and split open by what would have had to have been a massive bite force, such that could only have been given by another Tyrannosaurus rex. Additionally, there are what appears to be a set of smaller teeth marks on the bones that are not attributable to an adult Tyrannosaurus rex, and may indicate that a smaller individual also feasted upon this specimen. Along with Peter, the previously mentioned Y-Rex exhibits a noticeable lack of most of its tail, which could only have been achieved if another Tyrannosaurus Rex had rendered control of it from Y-Rex. As to whether or not the tail was actually eaten, we will probably never know, but it is not impossible that the victorious Tyrannosaur did eat Y-Rex's tail after winning whatever competition had been taking place. Even if not evidence of cannibalism, this is still excellent evidence of intraspecific combat between tyrannosaurs. More evidence of intraspecific combat can be found on another Tyrannosaurus specimen nicknamed Victoria. This particular specimen is noteworthy for having noticeable tyrannosaur bite marks along its lower and upper jaws, which seems to indicate craniofacial biting from another tyrannosaur, rather than simply cannibalism. And indeed, many other specimens may also show evidence of craniofacial biting. This shows that Tyrannosaurus rex would have frequently engaged in combat with members of its own species, if not strictly for consumption, but also for a great many other potential reasons. As for what these animals would have eaten outside of their own species, there is a fair amount of controversy surrounding their predatory nature. When Tyrannosaurus rex was first discovered, it was initially assumed to be an apex predator that would have hunted other dinosaurs for food. This belief was maintained for many decades as the animal itself became more and more well understood. However, this notion began to be challenged by some prominent paleontologists in the early to mid-90s. In 1993, paleontologist Jack Horner, the man who had previously discovered Maiasaura, would propose a radical new idea about Tyrannosaurus rex. In his book, The Complete T-Rex, he would suggest that, as opposed to the active hunter that had previously been imagined in the decades since its discovery, Tyrannosaurus rex was actually just a scavenger, in the same vein as modern-day vultures. This was naturally an extremely controversial position, though Horner did have some evidence that he believed would support a scavenger rex. To start off with, the olfactory bulb. that being the part of the brain dedicated to processing smells was exceptionally large in the brain of Tyrannosaurus rex. In fact, 50% of the entire brain was dedicated to this one sense. Horner concluded that this would have meant that the animal was capable of smelling animals or carcasses tens of miles away, which would have been analogous to animals today like vultures, which also have an extremely good sense of smell in order to guide them to carcasses. Along with this, he also cited T-Rex's famous bone-crushing bite as evidence of scavenger behavior, concluding that an animal that was feasting on soft flesh would not need to break open bones, while scavengers would need to be able to do this, as most of the nutritious meat had already been stripped off the animal by the time a scavenger would have arrived, thus meaning that a bone-crushing bite would have been required to get through the bones that were left behind, similar to animals like hyenas, which do the same thing and have immensely strong bites. However, it is important to note that this analogy with hyenas is actually a rather false one, considering that hyenas typically hunt most of their food more so than scavenging off of other animals' kills. Another piece of evidence Horner would go on to cite is that Tyrannosaurus rex would not have been an extremely fast animal, noting in the documentary The Valley of the T-Rex that the length of the femur was far longer than the length of the tibia, the ratio of which would seem to indicate that the animal was not built for any kind of speed, which Horner claimed in the documentary was the opposite of a fast-running animal.
The thigh bone is longer than the shin bone, which is the opposite of a fast-running animal.
This notion of slow speed is also backed up by recent papers, which show that adult rexes would have had a top speed of just 11 miles per hour. This lack of speed Horner proposed would mean that Tyrannosaurus would not be able to chase down prey, and was actually far better suited to using its incredible sense of smell to find rotting carcasses, walk miles to the already consumed animal, and then use its bone-crushing bite to eat what had remained. Additionally, Horner proposed that the famously small arms of T-Rex would have been completely useless for predation, as they would have been too small to help grapple with a struggling prey item and were significantly smaller relative to the size of the animal than other dinosaurs which were known predators such as Allosaurus. Meanwhile, a scavenger rex would not have needed long, powerful arms at all, as its meals would have been completely stationary. Naturally, this hypothesis drew a lot of criticism from the scientific community, and the debate over whether or not Tyrannosaurus rex was exclusively a scavenger, a predator, or a mix between the two became a hotbed issue in paleontology. Arguments against this hypothesis began being made almost immediately, and fossil evidence began to come forth soon after that would have almost completely invalidated the scavenger hypothesis, most important of which being the discovery of a Triceratops skeleton with Tyrannosaurus bite marks on various bones. While Tyrannosaurus bite marks on bones are nothing new, and only confirm T-Rex was feeding on the animal, they do not confirm whether the animal was killed or scavenged by the tyrant dinosaur. What made this find so interesting is that these bite marks were apparently healed, meaning that after this animal was bitten by a rex, it managed to get away and live long enough for the bones to heal, which necessarily means that a Tyrannosaurus rex individual had attacked a live Triceratops. While it is impossible to know the exact reason a Tyrannosaurus attacked this Triceratops, it is very likely that the attack was predatory in nature, as many scientists would go on to conclude, a fact that would cast doubt on Horner's scavenger hypothesis. As it stands now, the scientific consensus as to the predatory nature of Tyrannosaurus rex is that, while it certainly may have scavenged from time to time if the opportunity arose, active predation is still favored in regards to Tyrannosaurus rex behavior. As for other behaviors, one big question about Tyrannosaurus rex is how social they were. Social behavior in dinosaurs is fairly well documented, especially among living dinosaurs like birds. However, asking the same questions of long extinct dinosaurs is far harder. We know with some certainty that a few members of Carnosauria would have likely hunted in packs. Examples of this are animals such as Mapusaurus, which have been found together in massive bone beds of many different individuals that died at many different stages in their lives, indicating that they had lived in or at least hunted in a pack. However, as previously discussed, Tyrannosaurus rex is not a carnivore, so drawing conclusions from Mapusaurus might not be ideal, though there are members of Coelurosauria, particularly within T-Rex's own family, that may also exhibit similar behavior. Discovered on August 11, 1910 by the very same man who started this story, paleontologist Barnum Brown would unearth an incredible find in a quarry near the Red Deer River in Alberta. This find would consist of 26 individual specimens of the dinosaur Albertosaurus. This find is interesting as it consists of many different individuals of many different ages, but all from the same geological age. How they all died is still up for speculation, but the fact that they were all together when they died seems to suggest that these animals were living together in some kind of family unit. And because Albertosaurus is a close relative to Tyrannosaurus rex, both being in Tyrannosauridae, it would not be unreasonable to conclude that Tyrannosaurus itself may have had similar, if not the same, social relationships. Another interesting specimen is that of AWMM-IL 2022.21, nicknamed Barbara. Discovered in 2005, not only is Barbara one of a few T-Rex specimens believed to be gravid at the time of death, but she also shows signs of surviving while having a prolonged foot injury on the second metatarsal. The toe bone not only preserves swelling around the bone, but there's signs that show a tendon was ripped apart, giving Barbara severe physical pain and trauma. Considering that the injury is estimated to have lasted for about 6 months, it's believed she was able to survive thanks to the help of a potential mate that would have taken care of her while she was incapacitated and incapable of capturing her own prey. Just as with the case of Y-Rex missing its tail, this could possibly indicate that Rexes were extremely caring towards their partners and other family members, tending to their needs in times of injury and trauma. If this is indeed true, it could answer a lot of questions posed by the scavenger hypothesis, as we could see younger, faster individuals chasing down prey, while larger, less mobile adults await in ambush. Additionally, these kinds of social relationships and hunting strategies would seem to be supported by a 2024 paper that estimates that Tyrannosaurus rex would have actually been rather intelligent for a dinosaur, with some paleontologists saying it would have had an intellect on par with some modern-day baboons. Though it is worth noting that not all paleontologists agree with this paper. However, even if T-Rex did not hunt in large packs like Albertosaurus, based on what we know today with how living predatory birds rear their young, which themselves are close relatives to T-Rex, it would not be unlikely to expect that a small family unit could have been formed for a time, until younger individuals were ready to leave their parents. Alternatively, some scientists think that Tyrannosaurus may not have been social at all, noting the craniofacial biting and cannibalism discussed earlier, concluding that T-Rex was actually rather territorial and potentially solitary in nature. Though until more evidence is uncovered, the true nature of Tyrannosaurus' social behavior will still be up for debate. Yet despite the many unknowns and speculations surrounding it, there is, found within the being of the Tyrannosaurus, an incredible wealth of information about not just T-Rex itself, but all dinosaurs. From the largest of sauropods to the tiniest of birds, for 120 years, paleontologists have been able to uncover the most remarkable finds and have learned so much about this most impressive creature. So much so that this almost legendary animal has made its way into the popular conscience like no other dinosaur in history. Tyrannosaurus rex is unique among animals we have covered for Epoch Now in that it likely holds the title of the single most popular extinct animal to ever exist, and is quite possibly one of the most popular animals of all time. Due to this, T-Rex has what is likely to be the highest amount of pop cultural appearances of any animal we have ever covered or will ever cover on Epoch Now. Because of this, it would be rather impractical to cover every single piece of pop culture media that features the Tyrant Lizard King as we do with most of our videos. So instead, we will be taking a journey through the ages to see just how much the pop cultural depiction of this animal has changed over time, from its very first outing on the silver screen to its latest rendition in our modern era. After the original description of Tyrannosaurus rex in 1905, it would slowly and steadily gain in popularity over the years, until it made its very first appearance in the 1918 feature film by Willis O'Brien titled The Ghost of Slumber Mountain. Tyrannosaurus rex appears in this film in an outdated upright posture as the main antagonist to the short story. Prior to this, it had been featured in work by artists such as Charles R. Knight, and indeed the T-Rex in this film was based off Knight's original artwork. But this would be the first time the public ever saw a Tyrannosaurus rex moving around as if it were a real animal. From here on, the animal's popularity would skyrocket. O'Brien would then go on to produce another film featuring the animal 2 years later titled Along the Moonbeam Trail. However, it would actually be another film that would see the popularity of this animal truly explode. Based on the 1912 book by Sir Arthur Conan Doyle of the same name, a man by the name of Harry O. Hoyt would direct a film in 1925 known as The Lost World. Just as with O'Brien's original film, Tyrannosaurus rex would appear here too as one of the antagonists of the film, and is once again based on the outdated upright depiction of the animal that was popular at the time. In this film, it was seen doing battle with and eventually taking down a ceratopsian dinosaur as well as a sauropod dinosaur. The film was received incredibly well, making $1.3 million at the box office on a budget of $700,000, and is considered to be the first ever hit feature-length film to be made exclusively about dinosaurs. And while The Lost World did increase the popularity of the animal, it would actually be another movie releasing just 8 years later that would turn this animal into a titan of the big screen. On March 2nd, 1933, in New York City, a brand new movie would be released into theaters, a movie called King Kong. King Kong turned out to be a massive hit, making the equivalent of $124.5 million in today's currency. The actual story followed the story of an expedition to an unknown island where prehistoric animals still reigned. And while the movie was focused on a massive ape, King Kong, the ape itself did battles with many different prehistoric reptiles, including large bipedal predators known as meat eaters. Now, while the book nor the movie mentioned by name what these dinosaurs actually were, and the movie's director called them Allosaurus, the man who actually did the animation, the very same Willis O'Brien who's been with us from the very beginning, referred to these animals as Tyrannosaurus rex. And the public who watched this movie became enamored with this new massive dinosaur like never before. From here on out, Tyrannosaurus rex would be a household name and would come to be featured in countless movies and media since then. Over the next several decades, T-Rex would continue to increase in popularity, being featured in countless movies, books, and even TV shows. However, during this time, depictions of the animal rarely changed from the outdated kangaroo-like posture that it had held since it was first announced to the public. This depiction of the animal would begin to change, however, following the discovery and description of a dinosaur called Deinonychus. Deinonychus, discovered by paleontologist John Ostrom, was a small to medium-sized theropod dinosaur that was unique in its anatomy compared to other theropods known at the time. This was because Deinonychus presented clear evidence that it was not a sluggish reptile, but rather an active and, importantly, bird-like predator. The realization that dinosaurs had more in common with modern-day birds as opposed to cold-blooded reptiles would spark an era of intense scientific discovery known as the Dinosaur Renaissance. The Dinosaur Renaissance would see paleontologists rapidly change the face of what dinosaurs actually looked like, altering their postures and behaviors and even adding feathers to some of the dinosaurs that were closely related to birds. As for T-Rex, it would see the changes to its appearance come to life in paleoart and documentaries, with the first film to feature a Tyrannosaurus rex in the correct posture being the 1984 sci-fi movie by stop-motion animator Phil Tippett known as Prehistoric Beast. Additionally, scenes from this film would also be used in the full-length documentary Dinosaur that released the next year in 1985. While Prehistoric Beast was groundbreaking in its highly accurate depiction of the animal, the reality of the time was that the science was moving far faster than the public perception was, and the outdated view of Tyrannosaurus rex as a sluggish upright reptile would persist up until as late as May 14, 1993, with the release of a B-movie called Carnosaur. In order to bring the public perception of this animal up to speed with the science of the time, the entire world was going to need to see this animal like never before. And luckily, just a mere month later, a brand new movie would arrive in theaters, the likes of which the world could never have even imagined. A little-known film called Jurassic Park.
They got in there, King Kong?
Based on the 1990 book of the same name by sci-fi author Michael Crichton, Jurassic Park instantly became the biggest movie in the entire world, raking in nearly $1 billion at the box office. But perhaps most importantly, this movie was not just another dinosaur movie like those that had preceded it. Jurassic Park, in its premise of bringing dinosaurs back to life in fiction, sought to bring them back to life for audiences as well. And to do so, it based the designs of these animals not on the highly popular outdated depictions of the past, but on the latest science available at the time. This culminated in the arrival of perhaps the most legendary animal the world had ever seen. The Jurassic Park Tyrannosaurus Rex. In the movie, the T-Rex serves as a secondary antagonist to Dennis Nedry and the Raptors, being featured in several scenes showing off its power and active nature. Rather ironically, when Dr. Alan Grant asks how fast they are, in reference to the Brachiosaurus in front of him, Mr. Hammond responds,
"Well, we clocked the T-Rex to 32 miles an hour.
T-Rex? Mm-hmm. You said you've got a T-Rex?
Uh-huh. Say again. We have a T-Rex.
And later on in the movie, we actually see this happen when the Tyrannosaurus manages to chase after and keep pace with the gas-powered Park Jeep. With this, as well as the prominently featured velociraptors, Jurassic Park managed to completely break the public perception of dinosaurs as ancient sluggish reptiles, and reinforced the idea that these creatures were highly active and intelligent, like the birds they are related to today. In fact, this movie single-handedly brought the dinosaur renaissance to the public, and its depiction of dinosaurs would become the standard of what dinosaurs were to look like for the next several decades. And with regards to Tyrannosaurus Rex, Jurassic Park would cement this animal as the face of the franchise and the most popular dinosaur of all time. Following the massive success of Jurassic Park, director Steven Spielberg would go on to create a sequel releasing in 1997 known as The Lost World Jurassic Park, which featured not just a single tyrannosaur, but an entire family, one which was fiercely protective towards the small baby that they shared. This idea of Tyrannosaurus Rex as caring parents going to extreme lengths to protect their young was another idea from the dinosaur renaissance that Jurassic Park managed to bring to the public, breaking the mold once again. And following this movie, the Jurassic franchise would see 5 more movies, countless games, and even a few TV shows released, almost all of which would feature Tyrannosaurus Rex in an extremely prominent position as the figurehead of the franchise. But America would not be the only country to bring this animal to the big screen. Around the same time, but nearly 5,000 miles away on the other side of the Atlantic Ocean, a public service broadcaster in the United Kingdom, known as the BBC, would start production on their own dinosaur feature. Taking inspiration from the many nature documentaries they had produced in the years prior, the BBC would produce a revolutionary documentary like never seen before, envisioned as the first ever natural history of dinosaurs. In 1999, they would release the 6-episode miniseries Walking with Dinosaurs. Walking with Dinosaurs was considered to be a watershed moment in television history, bringing in nearly 19 million viewers on its first episode and maintaining above 15 million viewers for the subsequent 5 episodes. In fact, it is likely that Walking with Dinosaurs may have been the biggest science documentary series ever created, and by far the largest science program in all of British television history. Needless to say, this series, just as Jurassic Park did, attempted to bring the dinosaur renaissance to the public. However, where Jurassic Park did this through fiction, Walking with Dinosaurs would do this through a documentary series. This series would attempt to portray these creatures in their natural environments, as animals, as opposed to movie monsters. And the final episode of the series, Death of a Dynasty, would center entirely around a female Tyrannosaurus Rex living in the final days of the dinosaurs. The series would be hailed for its innovative depictions of these dinosaurs and its decision to portray itself as a nature documentary. From this success, it would spawn numerous spin-offs and other media and shows for the brand new Walking With franchise. But by far its biggest legacy would be the hundreds of TV shows that would result from the new technology that Walking With Dinosaurs had unleashed. Following Walking With Dinosaurs, countless dinosaur documentaries would be released to the public throughout the next 20 years, many of which, of course, featuring the king of the dinosaurs itself, Tyrannosaurus Rex. However, the Tyrant Lizard King's most prominent outing in the 21st century would have to wait over 20 years until the release of a new documentary, that being 2022's Prehistoric Planet. In 2022, the BBC, in collaboration with Apple TV, would release a brand new documentary series in a similar vein to their previous Walking with Dinosaurs series over 2 decades beforehand, but with this series utilizing all the advancements in science and technology to improve upon Walking with Dinosaurs in a massive way. And the very first scene of the show showcased a male Tyrannosaurus Rex leading its hatchlings to a meal across an ocean. It would be, to date, the most scientifically accurate Tyrannosaurus Rex ever seen on TV, incorporating the latest scientific knowledge into the design of this animal, giving audiences the closest possible experience to seeing a real-life Tyrannosaur. Through both seasons of the show, Tyrannosaurus Rex and a few of its closest relatives would appear numerous times, showcasing what it would look like in its natural habitat of Maastrichtian North America. And that brings us to today, in the year 2025. This journey, spanning roughly 120 years, has seen this animal take on many different shapes and sizes and become the most popular dinosaur of all time. And this year, we saw it return on the big screen in yet another Jurassic Park movie, as well as a Walking with Dinosaurs reboot, showcasing just how popular this animal is, and will continue to be for centuries to come. As far as other media goes, Tyrannosaurus Rex, as previously mentioned, quite possibly has the highest number of pop cultural appearances throughout the years since its discovery of any known non-avian dinosaur, with many different spotlights in TV shows, video games, movies, and documentaries. While it is impossible to cover all of them, we will still attempt to cover its more prominent appearances. Starting with video games, animals that look similar to Tyrannosaurus Rex have been featured in numerous games throughout time. However, the first confirmed video game featuring the Tyrant Lizard King would be in the 1992 Japanese dinosaur fighting arcade game Dino Rex. In addition to this, Tyrannosaurus has also appeared in a great many other dinosaur fighting games, examples of which include the Fossil Fighters franchise with the fire-type Vivosaur T-Rex. It also appears in the Dinosaur King franchise as a fire attribute dinosaur. It would appear as a ravenous predator in the game Combat of Giants Dinosaurs, and numerous others since the release of the aforementioned Dino Rex game. Outside of these fighting games, Tyrannosaurus Rex is renowned as a star attraction in several park building simulators. The first park building video game that it appears in would be in the 2002 Dinosaur Digs DLC in the first Zoo Tycoon game of the franchise. It would later appear in 2003's Jurassic Park Operation Genesis, colloquially known as JPOG, as a 5-star dinosaur. Other park building games outside of these can include the Steam-exclusive video game Prehistoric Kingdom, Jurassic Park Builder, Jurassic World the Game, the Jurassic World Evolution games, and many more. The Tyrant Lizard King has also made a significant number of appearances in first-person shooter or hunting games, starting in 1997 with the popular first-person shooter franchise known as Turok. Following this, the next hunting game featuring Tyrannosaurus Rex released the following year with the very first game of the Carnivores franchise. Other shooting and hunting games featuring Tyrannosaurus Rex include the Primal Carnage games, Dino Hunter Deadly Shores, and many other first-person shooter simulators. As far as survival games go, Tyrannosaurus Rex has also had a massive spotlight here as well, with the very first dinosaur survival simulator created that also included Tyrannosaurus being 2015's The Isle. Following the release of The Isle, many other dinosaur survival games featuring the Tyrant dinosaur would also be released, such as Saurian in 2017, Beast of Bermuda in 2018, and Path of Titans in 2020, just to name a few. Another survival game, but of a very different style, would come out the same year as The Isle, with the hit video game Ark Survival Evolved. This game, as well as the franchise it spawned, has starred Tyrannosaurus in many of its games and even a Paramount Plus show. Aside from the many video games to feature this animal, many TV shows have also incorporated the King of the Dinosaurs into their stories. Similar to video games, many of these TV shows showcase numerous unnamed creatures that resemble, but are nevertheless unnamed as T-Rex. That said, its first official TV show appearance would be in the 1974 Land of the Lost series as the commonly reoccurring antagonist, Grumpy. Jumping 3 decades forward in time into the 2000s, T-Rex would be showcased in the final season of the BBC fictional drama series, Primeval, and quite a lot in the 2019 Adult Swim series Genndy Tartakovsky's Primal, primarily as the protagonist Fang. As far as other TV shows go, Tyrannosaurus would most commonly be seen in children's shows. To start with, one of the most popular children's shows, that being Barney the Dinosaur, would star the titular character of the original 1988 series as a purple anthropomorphic T-Rex.
Honey, I'm home.
3 years later, in 1991, the comedy series Dinosaurs showcases Tyrannosaurus Rex as Earl Sinclair's best friend, Roy Hess. Aside from Barney and Dinosaurs, other popular children's shows that feature the Tyrant Lizard King are 2009's Dinosaur Train as the smart protagonist adopted into the Pteranodon family, Buddy, the Dino Dan franchise of the same year, the 2011 Cartoon Network show The Amazing World of Gumball as the semi-antagonist Tina Rex, the Netflix exclusives Jurassic World Camp Cretaceous and Chaos Theory, and many other famous TV series throughout the years. As far as movies go, Tyrannosaurus Rex has shocked audiences around the world outside of already groundbreaking blockbusters such as Jurassic Park, starting in 1940 with the Rite of Spring segment in the Disney movie Fantasia, where the Tyrant Lizard would be seen doing battle with a Stegosaurus. Along with these, it would go on to make numerous other appearances, such as 1980's The Land Before Time franchise with characters such as Sharptooth and the protagonist Chomper. T-Rex would also appear in the 1990's Toy Story franchise with Rex. It would also appear later on in the third Ice Age installment in 2009, Dawn of the Dinosaurs, and 2014 with the first depiction of the feathered Rex on screen in the Australian movie Dinosaur Island. As for other titles aside from the ones listed prior, Tyrannosaurus Rex would also make even more notable appearances in TV shows and documentaries, with one of its earlier appearances reusing footage from The Ghost of Slumber Mountain in the 1922 short film Monsters of the Past, The Story of the Great Dinosaurs. Around 70 years later, T-Rex would star in the IMAX movie T-Rex Back to the Cretaceous. Other docufilms that feature the King of the Dinosaurs also include 2016's NHK documentary T-Rex: An Evolutionary Journey and Giant Screen Films T-Rex of 2024. As far as docu-series go, Tyrannosaurus would star prominently within the 2006 BBC show Prehistoric Park. where in the first episode, time-traveling zoologist and adventurer Nigel Marven would rescue 2 juveniles from the KPG mass extinction and enclosure them in the section of the wildlife preserve known as T-Rex Hill. Post-rescue, the individuals, named Terrence and Matilda, would often be shown in viewing shots of the sanctuary, predominantly while fighting. Other notable documentaries that featured this incredible dinosaur would be 2001's When Dinosaurs Roamed America, 2008's Jurassic Fight Club, 2009's Clash of the Dinosaurs, alongside the spin-off docufilm 2010's Last Day of the Dinosaurs, 2011's Dinosaur Revolution, the 2023 Netflix exclusive Life on Our Planet, and numerous other documentaries throughout the years. In the end, Tyrannosaurus rex has risen in popularity so much that it has become a global icon, easily recognizable across every corner of the world as the king of the dinosaurs. Ever since it was first discovered as the fragmentary Manospondylus by Edward Drinker Cope all the way back in the 1800s to today, where it is by far the most well-studied non-avian dinosaur of all time. The history of Tyrannosaurus rex through both science and pop culture is one of the most fascinating of any prehistoric animal ever known. Every new discovery better informs us about the nature of this magnificent creature, and every new documentary and movie brings us closer to seeing this near mythical animal as it once was in a world long gone from today. But even an animal as mighty as Tyrannosaurus rex could not resist the tides of history, and many millions of years ago, this most impressive king of the dinosaurs would vanish from our world forever, leaving behind its fossilized legacy in the middle of the North American continent for us to uncover. But what exactly happened to this monumental creature? How did the Tyrant Lizard King finally meet its end? Tyrannosaurus rex had well earned its reputation as the king of all dinosaurs. For 2 million years, it ruled over the North American continent as the sole uncontested superpredator, the likes of which had never been seen before. And yet, no matter how mighty or powerful, all kingdoms do eventually come to an end. And 66 million years ago, the kingdom that Tyrannosaurus rex ruled would indeed come to a spectacular end in both fire and ice. For the longest time, paleontologists were not entirely sure as to the exact cause of the extinction of Tyrannosaurus rex, and indeed all other non-avian dinosaurs. However, it was known that around 65 million years ago, the Earth experienced a catastrophic mass extinction that saw mass die-offs of all types of life, not just the dinosaurs. As to what caused this mass extinction, prevailing theories at the time included an increase in volcanic activity, similar to what had occurred during the end Permian, or climate change that would have seen the Earth's climate become far too cold for what had traditionally been viewed as massive cold-blooded reptiles, resulting in their eventual extinction and replacement by warm-blooded mammals. However, one publication from 1953 suggested something else. Rather than volcanic activity or climate change, this publication suggested the extinction of the dinosaurs came about due to a cosmic event, where one or more meteors rained down upon on the planet, wreaking mass devastation on the Earth's biosystems. Initially, this hypothesis was widely rejected due to a lack of strong evidence. However, in the 1980s, a team of scientists led by physicist Luis Alvarez and his son geologist Walter Alvarez discovered that the Earth contained a layer of iridium metal in concentrations that exceeded normal levels by hundreds of times. Additionally, this layer was located above all known fossils of non-avian dinosaurs, suggesting that the extinction of the dinosaurs was related to the layer of iridium. Interestingly enough, this high concentration of iridium is what would lend support to the previous impact hypothesis, as asteroids are known to have higher concentrations of rare earth elements, such as the aforementioned iridium, and an impact of one on the Earth would leave behind a blanket of debris across the surface of the planet with a notably high concentration of iridium that was previously present inside the asteroid. And sure enough, around the same time as the Alvarez's discovery, the remnants of a truly massive crater would be discovered on the northwestern tip of Mexico's Yucatan Peninsula. At 182 kilometers in diameter, it is the second largest impact crater on the entire planet, and is dated to the same era as the layer of iridium that covered the Earth. Combining together the massive die-off of life in the fossil record, the layer of iridium that surrounds the globe, and a monumental crater in Mexico, all dated to roughly the same time, it begins to become horrifyingly clear as to what exactly happened on the last day of the dinosaurs. Crashing down from the heavens, a massive asteroid 10 kilometers across slammed into the Gulf of Mexico, in what we now know today as the Yucatan Peninsula. This asteroid struck the surface of the Earth with a force equivalent to 10 million Hiroshima atomic bombs, casting out superheated debris all over the planet, burning and incinerating entire continents' worth of ecosystems and life. Tyrannosaurus rex and its other North American contemporaries would have taken the brunt of this cataclysmic event, experiencing the worst of the asteroid impact and its fiery fury. However, for those individuals who, by chance, survived the initial fires of the asteroid strike, the next 10 years would be one of a devastating nuclear winter. For the asteroid in its impact dug up millions of tons of rocks and debris, the dust of which would blanket the atmosphere of the planet for the next decade, and in doing so, preventing most of the light and warmth given off by the sun from reaching the surface, rapidly cooling over the planet and killing most of the remaining plant life. This dramatic climactic upheaval proved to be deadly for 75% of all life on Earth, and not even the mighty king of the dinosaurs, Tyrannosaurus rex, could make it out alive. And by the time the dust had settled and the sun shone upon the face of the Earth once more, every single tyrannosaur had died. The Tyrant Lizard King was now extinct, its once mighty kingdom reduced to ash and dust. From these ashes, a new group of animals would rise to take the throne, for the age of the mammals had now begun. Yet even in death, this once mighty king continues to rule over the hearts and minds of millions of people alive today. So much so that the mere mention of the word dinosaur itself conjures up visions of this almost mythical animal. A body the size of an elephant, a head the size of a lion, with teeth like railroad spikes, and a bite force unrivaled by any other terrestrial animal. It's no wonder then that for the past 120 years, no other dinosaur has captured the imagination of the whole world quite like Tyrannosaurus rex, the king of the dinosaurs.
Brown has found and brought back many dinosaurs. Here is the head of the dreaded Tyrannosaurus.
But this ferocious 47-footer, the Tyrannosaurus, got his vitamins making meals of brontosaurus.
Tyrannosaurus rex was the largest flesh-eating animal to ever walk the earth, and it conjures up an image of absolute terror.
These teeth are unusual. They're strange. They're not sharp. They're like great steel railroad spikes. They're jamming into tendon and bone and splintering backbones and killing with one tremendous punch.
It's all for you, Stephen. Because we love dinosaurs.
On CBS This Morning, a glimpse at the largest Tyrannosaurus rex ever to have roamed the earth.
Tyrannosaurus rex, an animal that sparked the imagination for all of us.
Dinosaurs are really important, especially for kids, and to kind of grab them. They look at this, something like Tyrannosaurus rex, and it was a monster. I mean, a real live monster. This was something that actually existed, but it's a safe monster because they're all dead. Things like Tyrannosaurus rex and dinosaurs in general get kids asking questions about science.